Imagine a world without Google. How did we get from libraries and encyclopedias to instant answers at our fingertips? Learn the fascinating history of information technology and its impact on society. Greetings, time travelers. Welcome to Searching History, your portal to the past's most remarkable events. In the years before the transistor, electronics were powered by bulky and inefficient vacuum tubes. Vacuum tubes consumed a lot of energy, generated a significant amount of heat, and frequently broke down. This limited the size and capabilities of electronic devices. Bell Laboratories, the research arm of AT&T, sought a smaller and more reliable alternative. Enter John Bardeen, William Shockley, and Walter Brattain, a team of physicists with complementary expertise. On December 23, 1947, Bardeen and Brattain created the first working transistor at Bell Labs. Building on Shockley's theoretical work, they constructed a point-contact transistor using gold foil and germanium. The transistor revolutionized how current was controlled in electronics. Unlike vacuum tubes that required large voltages, the transistor could control current using only a small voltage. This represented a fundamental shift in electronic design. Smaller, more powerful, and energy-efficient devices became possible. The transistor paved the way for integrated circuits and microchips. Transistors served as the basic building blocks that could be placed closely together on a silicon chip. This led to incredible miniaturization and the microchip revolution. Electronics became smaller and more capable. The impact was felt across many industries, enabling calculators, computers, smartphones, and spacecraft. Over time, different types of transistors were developed with various applications. William Shockley invented the bipolar junction transistor. Later, the metal oxide semiconductor field effect transistor, MOSFET, was created. In 1956, Bardeen, Brattain, and Shockley received the Nobel Prize in Physics for their invention of the transistor. While revolutionary, the new technology also faced challenges related to materials and patent disputes in its early years. Two brilliant minds, J. Presper Eckert and John Mauchly, aimed to create a practical commercial computer after developing the ENIAC, the first general-purpose electronic digital computer. From 1946 to 1951, they worked on the UNIVAC I with funding from Remington Rand. The development involved innovative technologies like mercury delay lines for memory and magnetic tape for storage. When completed, the UNIVAC I was an enormous machine. It weighed a massive 13 tons and contained over 5,200 vacuum tubes. Despite its size, it could perform nearly 2,000 operations per second, surpassing any other device. As the first commercial electronic computer, it represented a revolutionary shift from slower punch card machines. One of UNIVAC I's first major uses was predicting the outcome of the 1952 presidential election. CBS News used the computer, which accurately called Adlai Stevenson's defeat to Dwight Eisenhower. From there, both government agencies and businesses utilized its powerful processing. It helped the U.S. Census Bureau with data analysis and performed ballistic missile calculations for the military. The UNIVAC I had a profound impact on society. It streamlined processes for government and revolutionized data management for businesses. Its capabilities also sparked public interest in computers. However, its immense size, high cost, and need for specialized operators meant it wasn't accessible to all. While short-lived, the UNIVAC I paved the way for smaller, more user-friendly computers. It truly laid the foundations for the digital age we know today. In the 1960s, the United States government sought to create a communication network that could withstand attacks during the Cold War. Funded by the Advanced Research Projects Agency, ARPA, this network was designed without any central hub. This meant information could still flow, even if parts of the network were damaged. The first nodes of this network connected 4 major universities: UCLA, Stanford, UCSB, and MIT in 1969. Dedicated phone lines linked these universities together, allowing them to share resources and collaborate across long distances. Researchers worked to develop the protocols that would govern how information was transmitted over the network. The Network Control Protocol laid important groundwork for future internet protocols like TCP/IP. Beyond universities, the network soon expanded to include other research institutions, government agencies, and eventually other countries. A major development was the sending of the first email in 1971. This revolutionized how people communicated and collaborated. Around the same time, Tim Berners-Lee developed the World Wide Web while working at CERN, building upon the existing ARPANET infrastructure. Just as importantly, the ARPANET had social and cultural impacts. It fostered new online communities and made knowledge sharing much easier. This laid the foundation for the collaboration we see online today. Of course, limited access, security concerns, and lack of standardization presented challenges early on. Ultimately, the ARPANET paved the way for today's massive global internet. By connecting billions of people worldwide, it has transformed how we live, work, and share information. Its decentralized design proved visionary and helped create a communication platform that has lasted for decades. Before the 1970s, computers filled entire rooms and were inaccessible to most people. The idea emerged to integrate transistors and circuits onto a single chip, creating a miniaturized computer brain. This would make computing power portable. In the early 1970s, companies like Intel, Texas Instruments, and others raced to develop the world's first microprocessor. Intel launched the 4004 chip in 1971. Though limited, it demonstrated computing's future, a computer on a chip. More powerful microprocessors followed, such as the Intel 8080 and Motorola 6800. Their increased capabilities and falling prices made computers personal. Where rooms once housed computers, now individuals and businesses could access affordable computing power. Society was transformed. Personal computers entered homes and offices, changing communication, education, and entertainment. Mobile devices like calculators, watches, smartphones, and tablets now power our portable lives thanks to microprocessors. Factories automated as microprocessors controlled robots, appliances, and devices. Moore's law observed transistors on chips doubling every 2 years, driving continued advancements. Challenges around power, heat, and miniaturization pushed the limits. Still, microprocessors progress artificial intelligence, quantum computing, and more. From filling rooms to powering our world, the microprocessor revolutionized computing and society. In 1975, MIT released the Altair 8800 computer kit for just $439. As the first popular personal computer, it ignited tremendous interest. Though it had no screen or keyboard and required assembly, tech enthusiasts and programmers eagerly embraced the challenge. When the Altair appeared on the cover of Popular Electronics magazine, it drove massive demand. People were fascinated by the idea of owning their own computer. Early adopters formed a vibrant community to share knowledge and develop software. This helped make personal computing more accessible. Pioneers created programming languages like BASIC for the Altair, fueling software development. Some of today's biggest tech companies, like Microsoft and Apple, trace their roots to the Altair era. The Altair shifted computing out of big institutions and empowered individuals to be creative with technology in their own homes. Beyond its technical impact, the Altair sparked people's imagination about the future. It represented the possibility of individual empowerment through technology. The personal computer was no longer just for engineers and scientists. The Altair helped launch the digital revolution that now permeates almost every aspect of life. Before email, communication relied on slower methods like physical mail, telegrams, and telexes. In the 1960s, researchers at ARPANET developed one of the first wide-area computer networks. This allowed them to exchange electronic messages, pioneering what we now call email. Raymond Tomlinson sent the first email message in 1971. His innovation marked the beginning of a new era of digital communication. In the following decades, the rise of personal computers and online services like AOL helped popularize email for personal and business use. Standards like SMTP and POP3 allowed different email systems to connect with each other. Email transformed how people connect around the world. Messages could be sent nearly instantly between any 2 points on the network. Businesses leveraged email to speed up workflows and processes. Schools and universities embraced email to facilitate collaboration between students and faculty. For individuals, email provided an easy way to stay in touch with friends and family regardless of distance. Of course, new technologies also introduced challenges. Spam became a widespread problem as marketers exploited open email systems. Online communities grappled with issues of privacy and appropriate etiquette. But email continued to evolve, adding new capabilities like file attachments, emojis, and even video conferencing. Today, email remains one of the most widely used applications for both personal and professional digital communication. The original Macintosh computer was more than just a machine. It revolutionized technology and changed how people interacted with personal devices. With its iconic 1984 Super Bowl commercial, the Macintosh challenged the text-based DOS interface by introducing an intuitive graphical user interface. At the heart of this new interface was the mouse. By allowing people to simply point and click, the mouse made computing accessible in a whole new way. Icons and a "what you see is what you get" display also made the Macintosh experience very user-friendly. Beyond its groundbreaking interface, the Macintosh had an innovative design. As an all-in-one device with a built-in screen and keyboard, it offered a sleek and compact style. Software like Mac Paint and PageMaker also helped make the Mac popular for tasks like graphic design and desktop publishing. Apple's distinct marketing and focus on community further contributed to the Macintosh's success. Though it remained a niche product compared to Windows PCs, the Macintosh left a huge mark. It forced other companies to rethink their user interfaces, which ultimately benefited all computer users. Most importantly, it established the graphical user interface and mouse as industry standards, influencing the design of technology for decades to come. In the 1980s, Tim Berners-Lee was working at CERN, the European Particle Physics Laboratory. He came up with the idea of a hypertext system to help researchers easily share information between computers. Berners-Lee invented hyperlinks that could connect different documents together. He also created HTML, a language for defining the structure and layout of web pages. In 1991, Berners-Lee launched the World Wide Web project. Now anyone with an internet connection could access information online. Early web browsers like Mosaic and Netscape made the web easy to use and explore. People quickly saw the potential of this new technology. Companies soon realized the commercial possibilities of the web. Search engines like Yahoo and Google helped people find what they needed online. Stores like Amazon showed how the internet could be used for shopping. The web connected communities and cultures all over the world. It changed how we learn, do business, and communicate with each other. As the web grew, new ways of using it emerged. Social media sites like Facebook and YouTube let people share content and interact online. With smartphones and tablets, the mobile web let us access information anywhere. Apps and mobile-optimized sites transformed our experience of the internet. Today, new technologies continue to push the boundaries. Concepts like blockchain, virtual reality, and the metaverse promise even more exciting ways we'll connect and experience the World Wide Web in the future. The story of the web is still being written. While Mosaic may not be as widely known today as some other pioneers of the internet, it played a crucial role in popularizing the World Wide Web and shaping how we interact with information online. Mosaic was developed in 1993 by Mark Andreessen and Eric Bina at the National Center for Supercomputing Applications. Unlike earlier text-based browsers, Mosaic offered a visual interface with clickable links, images, and scrolling. This made navigating the web significantly easier and more intuitive, attracting a wider audience to experience the emerging online world. Mosaic's release led to rapid adoption. Within a year, it became the dominant web browser, surpassing text-based alternatives. Its success also spurred competition, with Netscape Navigator emerging as a rival. This sparked the browser wars that drove further innovation. Though eventually replaced by newer browsers, Mosaic laid the foundation for the browsing experiences we take for granted today. Beyond usability, Mosaic introduced important technical foundations still used on the modern web. It included features like bookmarks, browsing history, and image embedding. Perhaps most importantly, its simple graphical interface made the web accessible to many more people. This impacted fields like education and research by opening access to online information. Mosaic also helped spark the initial internet boom. It fostered new online communities and shifted how people interacted with emerging technologies. Google started as a simple search engine created by two Stanford students, Larry Page and Sergey Brin. Their revolutionary search algorithm, called PageRank, prioritized relevant search results over simple keyword matching. This made Google's search experience much more intuitive than other options at the time. Google quickly gained popularity on the Stanford campus and beyond. It was initially called Backrub, but was later renamed Google to reference the large number Google. By focusing on relevancy over keywords, Google transformed how people accessed information online. Beyond search, Google built an entire digital ecosystem. Gmail revolutionized email in 2004 with useful features like search and large storage. Google Maps launched in 2005 and changed navigation with its satellite imagery and turn-by-turn directions. YouTube was acquired in 2006 and became a major entertainment platform for sharing and creating videos. Android, released in 2008, became the dominant mobile operating system, powering billions of smartphones and tablets. Google also offers cloud computing services through Google Cloud Platform. Today, Google remains heavily invested in emerging technologies like artificial intelligence, self-driving cars, and more. While greatly improving access to information worldwide, Google's data collection practices have raised privacy concerns. As Google's dominance has grown across search and other areas, it has also faced increasing antitrust scrutiny regarding its market power. Overall, Google has undeniably transformed how people interact with technology on a global scale. Napster revolutionized the music industry but faced legal challenges. In 1999, Sean Fanning, a college student, developed Napster, which allowed users to share music files directly with each other without going through record labels. This peer-to-peer system became wildly popular, gaining millions of users who enjoyed free access to a huge music library. However, Napster also disrupted the traditional music business model. Record labels were concerned about losing sales and felt that artists weren't being properly compensated. This led to a major legal battle as the Recording Industry Association of America sued Napster for copyright infringement. In 2001, Napster was shut down by the courts. Though Napster was gone, its impact remained. The company was later acquired and relaunched as a subscription service. More importantly, Napster paved the way for modern music streaming platforms like Spotify and Apple Music. It showed that people were interested in accessing music digitally rather than owning physical copies. This shift transformed the industry's entire focus to streaming subscriptions. Beyond the legal issues, Napster had cultural significance. It helped music fans discover new artists and connect through shared interests. While debates continued around digital rights, Napster proved that new technologies could revolutionize how people experience music. Its legacy continues to be felt in today's streaming-dominated music world. In 2000, Jimmy Wales and Larry Sanger launched Nupedia, an online encyclopedia where experts wrote articles. The following year, Wikipedia emerged as a collaborative platform where anyone could edit and contribute content. Wikipedia quickly grew popular due to its open and collaborative nature. People from around the world contributed to and read the freely shared knowledge. By allowing diverse voices and perspectives, Wikipedia's content reflected different insights and cultures. Edits were transparent and reviewed by the community to ensure accuracy. While Wikipedia brought more information to more people, challenges remained. Some worried about misinformation or bias influencing topics. Disagreements occasionally emerged as people debated disputed issues. Maintaining quality also required ongoing efforts as Wikipedia relied on volunteers and donations. Despite obstacles, Wikipedia has significantly impacted how knowledge is created and shared. It has empowered individuals to both learn from and contribute to the growing pool of information. Students, researchers, and the public now use Wikipedia as an important educational resource. Wikipedia's story reflects how collaboration can spread knowledge around the world. Facebook began as a way for college students to connect at Harvard University in 2004. Created by Mark Zuckerberg, it allowed users to share profiles and information. The social network quickly grew beyond Harvard, expanding to other universities and then opening to the public. Millions joined from around the world, transcending borders and cultures to foster new connections. As Facebook attracted more users, it evolved how people interacted and consumed information online. The personalized newsfeed algorithm curated what people saw, influencing discourse. People changed how they communicated, shared news, and participated in movements. Meanwhile, businesses leveraged Facebook's large user base for advertising, marketing, and customer relationships. However, Facebook's vast data collection and targeted advertising raised serious privacy concerns. Debate focused on user control over personal information and data usage. Additionally, the spread of fake news and misinformation on the platform threatened trust and social cohesion. Balancing freedom of expression with responsible content moderation also proved challenging. Facebook's impact extended into social and political realms. It played a role in movements and elections worldwide, sometimes exacerbating polarization. Concerns emerged about potential negative effects on mental health from overuse. Looking ahead, Facebook's metaverse ambitions raise questions around the future of online identity and interaction. After starting as a way for students to connect, Facebook evolved into a global platform that transformed communication and information consumption. While fostering new connections, it also faced ongoing issues around privacy, misinformation, content policies, and the impacts of social media use. The iPhone was launched in 2007 by Steve Jobs, revolutionizing the mobile industry with its multi-touch interface and integration of internet, media, and phone functions. Its intuitive design and app ecosystem popularized smartphones, changing how people communicate, consume media, and access information on the go. However, early models had limitations like battery life, limited storage, and slower network speeds. Over the years, iPhones saw significant hardware improvements such as better cameras, displays, processing power, and battery life. Software innovations through iOS updates introduced new features enhancing capabilities, including Siri, Face ID, augmented reality, and health tracking. The App Store became a major platform for developers and users, offering millions of apps for productivity, entertainment, and other needs. iPhones have become central to social media usage, messaging, and online activities, shaping communication patterns and social norms. While offering opportunities, their cost and data access limitations can create a digital divide. Data collection and targeted advertising also raise privacy concerns, prompting debates around user control and security. Future directions may include deeper integration with augmented reality, virtual reality, and foldable displays. Growing concerns about environmental impact and ethical sourcing of materials are also issues. Ongoing competition and innovation in design, features, and experience help drive the iPhone further. Cloud computing has transformed how businesses and individuals use technology. Instead of storing data and running applications on local servers or personal devices, cloud computing allows access to computing resources over the internet. This delivery model offers several advantages in today's digital world. Through cloud services, users can access all the tools and processing power they need without the upfront costs and effort of managing physical hardware. Resources like storage, databases, servers, and software can be provisioned instantly as needed and scaled up or down dynamically based on demand. This flexibility allows companies to avoid over-provisioning for peak usage and save costs. The three main types of cloud services are infrastructure as a service, IaaS, platform as a service, PaaS, and software as a service, SaaS. IaaS provides basic computing and storage, while PaaS delivers a layer of development tools and services on top of the infrastructure. SaaS handles full applications that are managed remotely by vendors and accessed via browsers. Cloud computing has evolved rapidly since its early beginnings in mainframe systems with limited access. Virtualization technology allowed more efficient sharing of physical servers among multiple users. Today, leading cloud providers like Amazon Web Services, Microsoft Azure, and Google Cloud offer their massive global networks as public cloud platforms for businesses and individuals. Many organizations also implement hybrid cloud strategies that blend public and private cloud services. Industries across the board now leverage the cloud. Businesses gain agility to innovate faster, support remote work, and glean insights from large data sets. Healthcare providers store patient records, enable telehealth, and advance medical research through the cloud. Education institutions deliver online learning and collaboration tools via the cloud. Entertainment companies rely on cloud infrastructure for streaming, gaming, media production, and content distribution worldwide. As the journey of information technology continues, where will it take us next? Thanks for joining us on this journey through history, friends. If you enjoyed this video, please hit that like button, subscribe to Searching History for more, and comment down below. Until next time, keep digging, keep exploring, and keep searching.